Hello everyone, I am Rajdeep Singh from SIRT Excellence, the SAGE Group. And in today's video, I am going to discuss about the introduction of a subject that is theory of computation, which will be taught in CS 5th semester, BTech CS 5th semester. So starting with the introduction, firstly I will discuss the scheme of the subject, and this is the scheme of the subject, in which the subject code of theory of computation is CS501, and in total this subject contributes 150 marks in the results. How this 150 marks is distributed? So the end semester exams, the main RGPV exams, will comprises of 70 marks. Mid semester will be of 20 marks for the semester, and quiz and assignment will be of 10 marks. Now this is the 100 portion, 100 marks portion is of theory, and rest 50 marks will be for practical portion. So right now I'm going to give an introduction about theory part. In next video I will also discuss about the practical portion, that what all practical will cover in this subject. Okay, so first of all I will discuss the prerequisite. So before starting this subject, one should have basic knowledge of discrete mathematics, the concept of set theory, strings, length, alphabets, etc. Very basic knowledge of data structures and algorithms. After that, the question arises that what is TOC, or theory of computation. So theory of computation, or sometimes it is also known as automata theory, is a theoretical branch of computer science and mathematics which mainly deals with the logic of computation. Theory of computation actually tells us that how a problem can be efficiently solved on a model of computation. So we focus on the model of computation to solve a program or solve a problem efficiently. What this is what we are doing in this theory of computation. In theory of computation, this subject is mainly divided into three portions. First is automata theory, computability theory, and complexity theory. And these all things are broadly divided into 5 units in this subject. So starting with the syllabus, I will give the brief overview of every unit, that what we are going to study in each unit. So unit 1 is the basic introduction of automata theory, that what is finite state machine, what all automata machines we are going to study in this whole subject. We'll also have a overview of types of machines, that is finite state machine with output and without output, their conversion among them. So this is an introduction portion of this theory of computation or automata theory. In unit 2 we'll go in depth about what finite automata is and what are the finite state machine. We'll discuss in depth that what are the non-deterministic finite automata and what are the deterministic finite automata, their conversion among each other, and minimization of the machine if it is redundant. Moving on to unit 3, we'll study the context free grammar, context sensitive grammar, and all the grammars which are there in this subject. So, and the normal forms also, where the grammar, if some operation is to be applied on the grammar, then what normal forms we have to apply on that grammar. In unit 4, we'll study about push down automata. These push down automata are actually the practical implementation of parser. Parser is a word you might have heard in the compiler design topic. So this push down automata is actually the practical implementation of those parser. We'll discuss about types of push down automata, how a context free grammar is mapped into PDA, and how a PDA is mapped into context free grammar. So these are the things which we are going to study in unit 4. And likewise, in last unit, we will discuss about Turing machine, which is the most powerful machine which we are going to study in this subject. It is also known as universal Turing machine. We'll also discuss about the complexity theory a little bit, and about some computation problems like halting problem, post correspondence problem, etc. And so these are all things which we are going to study in this subject, that is theory of computation. And in last, I will illustrate the applications where these theory of computation subject is used. So first and foremost, it is used in various phases of compiler design. Whenever you have seen the languages like C++, Java, Python, and many more. So all of these languages have their compiler with them, which translate the high level language program to machine level language program. So that compiler, that software which is called as compiler, is designed by the use of the basic concept which we are going to study in theory of computation. We also design text editors and spell checkers by using the concept of machines and automatas. We evaluate the arithmetic operation by the help of these machines. In at the high end application, these automata theory and this theory of computation is also used in the implementation of genetic programming, neural networks, robotic applications, and artificial intelligence. So this was all about the introduction of this subject theory of computation. In next video, I'll discuss about the what all the things which we'll cover in practical portion of this subjects. So for now, thank you so much.